Alright fellas, let's dive into this topic on permutation in groups. This topic is crucial for understanding abstract algebra.
Yeah, I've been looking forward to this. So, we're talking about permutations, which are basically rearrangement, right?
Exactly, but it's not just any old rearrangement. We're talking about permutations, as bijections form a set to itself. It's a bit more formal than just shuffling things around.
Right, so we've got a set like A, B, C, and we can rearrange it into different orders. But each arrangement is like a function that maps each element to a different position.
Ah, got it. So, like if we switch A and B, that's one permutation. And if we switch B and C, that's another one.
Precisely. And when we talk about combining these permutations, we're talking about function composition. So if we apply one permutation and then another, we get a new permutation.
That's the ticket. And the cool thing is this composition operation is associative, just like regular function composition.
So, it doesn't matter in what order we combine them, right?
Yep, you got it. And because composition of bijections is a bijection itself, we have closure under composition. Composing two permutations always gives us another permutation.
And check this out, fellas. We've got an identity element too. The identity permutation just leaves everything unchanged.
Nice. So if we compose any permutation with the identity, we get the original permutation back.
Exactly. And every permutation has an inverse which undergoes its effects. So if we compose a permutation with itself with its inverse, we get the identity.
This is starting to sound like a group.
Yeah, it's all coming together. Permutations, composition, identity, inverses, it's all there.
You got it. And we denote the group of all permutations of a set as A sub S sub A, or if it's the set of the first n positive integers, we call it S sub n.
And any subgroup of these symmetric groups is also a group of permutations.
So, like a subset of all possible rearrangements still forms a group under composition.
Exactly. And there's a lot more to explore with symmetric groups. We can dig into specific examples and see what kind of structures emerge.
Absolutely, understanding these groups of permutations opens up a whole new world of possibilities in abstract algebra.
I'm pumped to dive deeper into this stuff. Group theory is wild.
That's the spirit, babes. We're talking more examples and concepts in the next session. Stay tuned, fellas.
Thanks for breaking it down, Carolina. This stuff is so fascinating.
Yeah, thanks for guiding us through it. Can't wait for the next one.
Anytime, guys. Group theory is where it's